What is permafrost and how do engineers in Alaska build on it? This is a photo I took of permafrost in Utqiagvik. You can see the gas bubbles trapped in it. What is permafrost? It is a soil rock that remains frozen for 2 or more years. This is a very famous house in Fairbanks that has been affected by permafrost. It was ill-built for the region, and what has happened is subsidence of the ground. Keep watching this video to learn more about the processes that took place to have a house be in such dire condition. First up is, how does permafrost grow? There is epigenetic permafrost, which is where the ground was already there and conditions changed where the ground was able to be frozen. It grows from the top down, if you think about it. Next, there is syngenetic permafrost, which is where the soil is deposited and promptly frozen, and this happens in layers. So you could think of it as growing from the bottom up. And what happens here is it's always rich in organics and higher in water content. There is also multi-stage ice wedges where thermal cracking occurs. Small cracks occur in the ground. Water goes into the cracks, freezes, and expands, and that happens over and over, and you can have something that looks like this for a wedge. What are the different types or regions of permafrost? Firstly, there is continuous permafrost, where a majority of the ground is composed of permafrost, over 90%. Then there is discontinuous permafrost, where 50 to 90% of the ground is frozen. Then there is sporadic permafrost, where 10 to 50% of the ground is frozen. There is also subsea permafrost, which is the seafloor is a frozen ground. Here is a profile view comparing discontinuous and continuous permafrost, moving from discontinuous to continuous. You can see it gets deeper, and it is a solid amount frozen. There is also an active layer shown here in the dark part. The active layer is a small strip above the permafrost. It is comprised of soil and organic material that freezes and thaws in the summer and winter. And in discontinuous permafrost, it is thicker compared to continuous permafrost. Here is a map of Alaska showing the different types of permafrost across the state, from continuous to discontinuous, sporadic, and isolated. Next is how to visually determine a permafrost area or to identify factors that influence permafrost in a region. Firstly, there is climate. Is it cold enough to sustain or to grow permafrost? Is the winters cold enough to mitigate the thawing of the summers? Next is topography. A higher elevation indicates more likelihood for permafrost, especially on hills. It is the northern side compared to the southern side, where the southern side experiences radiation from the sun, and typically there's not permafrost due to that heat there. There's also the soil and rock material. There is non-frost susceptible soil like gravel. Gravel doesn't hold a lot of moisture in it, so there isn't anything to freeze. In comparison to silt and clay, where there is a higher moisture content, there's more water in it, so it more readily freezes. Next is disturbances. Has there been any type of equipment, machinery? Has trees been cut? The equipment, the heat from the engines can thaw the permafrost quite easily, and when you cut the trees, that also contributes to a degrading permafrost. Next is looking at vegetation. black forest spruce and the lower shrubbery and dwarf birch indicate a permafrost zone where alder or larger spruce trees don't indicate permafrost necessarily, because the larger trees have larger roots, and so they need to go deeper into the ground, where that is prohibited because the permafrost has the ground super solid. And the open black spruce forests, they provide canopy, which reduces snow coverage on the ground, and snow is an insulator. If you've ever built a little snow cave, you know it's actually typically warmer inside the quote-unquote snow cave than outside in the air. So if the black spruce forest is holding the snow above the ground, it allows the cold temperatures of the air to penetrate the ground and keep it frozen. Then moss and peat also help with sustaining permafrost, because peat allows cold air to go through it in the wintertime, but limits the heat from the summertime from penetrating the ground. Here are two photos. On the left is black spruce and on the right is dwarf birch, which both indicate a permafrost area. What are some other visual features? Here are polygons. There are low-centered and high-centered polygons, and how these form is thermal cracking in the ground. The freeze and thaw in the winter and summer can create these cracks where water accumulates in the cracks, freezes in the winter time, and expands and creates these ice wedges you can see here, which create the low and high-centered polygons. Here is some real-life photos of low-centered and high-centered polygons. This is typically in continuous permafrost zones, and especially in northern Alaska. Another thing is frost heaving. If you've ever driven or ridden in a car in Alaska, you've also experienced frost heaving, which are these dips and rolls in the ground surface. And this happens again because of freeze and thaw, and also the capillary rise of water, which travels towards the surface of the road, freezes, and expands. For homes, how do you build on permafrost so that you're not degrading it, like that photo I showed previously? A good practice on continuous permafrost, and especially in northern rural Alaska, is to build on piles. You are decoupling the heat of the house and the ground. So what you're doing is you want to have airflow going underneath the house, so that the heat, because obviously you want your house warm, so the heat of the house doesn't travel into the ground. So the air is flowing underneath and cooling the heat coming from the house so that it doesn't go into the ground. Another thing is thermosiphons. They're used to keep the ground frozen and act as a stabilizer. This is a photo of the Trans-Alaska Pipeline, and here you can see the thermosiphons stabilizing, because if there is any subsidence that happens here, it can damage the pipeline, and that would not be good for Alaska's economy. There is also Here is some more information on thermosiphons. They are a passive system, which is really great, and they can be used and be effective in either just exclusively the winter, or in the winter and summer. And how they work is there is a sealed tube with fluids, either carbon dioxide, ammonia, or propane. And there is an evaporator pipe in the ground and a radiator above the ground. And this process happens when the air temperature drops below the soil temperature in the wintertime, and it will cool the gas or liquid in the tube. It will go towards the bottom and into the ground and evaporate into the warmer ground, and it will convect within the pipe, much like the mantle of the earth. And in the summertime, if it is built to do it, it will evaporate the heat of the ground and into the air when the ground is warmer than the air, or when the ground is, yes, in the summertime. What does climate change mean to Alaskan infrastructure? So how does climate change affect the Arctic? First of all, there is Arctic amplification, which is where climate change is more negatively, and the process starts quicker in the Arctic, so we are experiencing it a lot more in higher latitudes than in closer to the equator. Then the thawing of permafrost causes a negative feedback loop. Permafrost holds the organic materials, and when it thaws, the organic materials are decomposing, which contributes greenhouse gases to the atmosphere. And for infrastructure, it means subsidence and erosion. So in this photo here, you can see that the building is being affected by subsidence because permafrost is frozen water, frozen material, and when it thaws, it will lose volume, and that can happen in different locations of the pad of the house, wherever the house or building is, and it can make it sink or slide around on whatever the foundation is. There is also erosion that happens on the coast, and Alaska, mainly a lot of the communities are on the coast due to accessibility and having things shipped there via boat. And for erosion, there is the increasing negative weather conditions, and also in the wintertime there is less sea ice, and that allows more erosion to happen on the coast, and the ground is frozen with permafrost, and if the water touches the permafrost, it very quickly will degrade it and cause more destabilization of the coast and higher amounts of erosion. And it will also affect water quality and water availability. The work I'm working on is water quality. So again, permafrost stabilizes the ground surface, and whatever is in it will be released into the environment if it degrades and destabilizes, whether that again is organic materials, heavy metals, or anything. It will go into the water, it can leach into the water and decrease the water quality. And with water availability, it can just kind of more easily spread and not be contained into lakes or rivers. An activity that you can do to apply this knowledge is you can take a walk, or the next time you're on a plane or driving in a car, you can observe your surroundings, think about the features, whatever the vegetation, what is your latitude, and what are you seeing, and you can decide if there is permafrost there. You can form a hypothesis based on where you live, and you can reference this video again and look at that map, or you can look up the permafrost map of Alaska and see if you are correct. Here are my references. Thank you for watching my video. Bye!